Ever been curious about rim widths, spoke count, asymmetric designs, what hookless means, or well, anything else about wheel rims? This is the video for you. So today we're talking all things mountain bike rims. Let's get stuck in. Before we get in too deep, let's talk about the basics of rim design. We've got the outer wall, we've got the inner wall, these are the side walls, this is the rim bed, and these are the spoke holes. And if we had one on this, you'd have a valve hole too. When it comes to rim sizes, you've heard of numbers like 27.5 or 29 or 650B or 700. These refer to the diameter of the wheel rim. Mountain bike rims will usually be measured up in inches, with gravel or road rims measured in metric. Sometimes they're used interchangeably, with 650B being the same as 27.5 as one example. Things get a bit more complicated beyond that, but we'll get into that later in the video. So, how are they made? Rims are usually made from either aluminium alloy or carbon fibre. The internet has a lot of opinions when it comes to carbon versus alloy, but we'll park that to one side for now. Let's have a quick look at how they're made. Aluminium rims are made from a long piece of extruded material. They look a lot like a long straight version of this, but made out of metal. That then goes through a big rolling machine and gets bent into a hoop, which ends are joined in the middle to form the rim. The quality of this join is not only key for strength, but also good at creating a seal when using a tubeless setup. And add some spoke holes and that valve hole, and you're more or less good to go. Because of that construction process, most aluminium rims often have a simpler design compared to their carbon counterparts, with material properties of the rim staying consistent all the way round. Carbon rims, though, are made differently. The sheets or strands of the carbon fibre will be laid up in a very special order in a rim-shaped mould. Then sort of a bladder, think of a big balloon, is fitted inside that mould to force the carbon into the mould. The mould is subjected to a lot of pressure and heat, and hey presto, we've got ourselves a carbon rim. Add some drilling and some finishing, and that's our carbon rim sussed. Not only can carbon be manipulated into some phenomenal shapes, but by playing with the layup, engineers can tweak and optimise the performance properties of the rim in different areas. This gives engineers much more control over things like weight, strength, compliance, all that good stuff. That gives us an overview of a mountain bike rim, so let's get into that nitty-gritty. Let's start with rim width. When it comes to rim width, we have two key measurements to address. We have external, which as the name suggests is the extreme outside to outside, with the internal being the distance between the two inner edges of the rim's sidewall. And then we've got the external sort of sidewall thickness. Now, this is the relationship between the internal and external measurements, and it can determine sidewall thickness. So as I briefly mentioned, sidewall thickness can play on how well your tyre bead is supported once inflated. With a minor increase in mass, a thicker sidewall will not only be stronger, but also give more resistance against pinch flats, having a softer, rounder edge to it, like on these hookless designs. And the internal, this is the measurement most brands headline and will advertise when it comes to rim design. As you may already have guessed, that's what the I30 in gradient I30 stands for. It was previously thought that narrower tyres were faster across all disciplines of riding. Now that's been widely disproven, we're seeing riders the world over adopt wider tyres. As a result, we're needing the wheel rims to match. Getting your wheel and tyre combo correct not only impacts performance, but also safety. So, too narrow a tyre for the wheel rim will make the tyre have a bell-shaped profile, overloading and exposing the sidewall. As well as this, the tread lugs will not engage the terrain as they should, leaving you short on grip. Too wide a tyre for the rim will give you a very round profile, which will be very unstable with a very high chance of rolling the sidewall, debigging the tyre under cornering load. So when you put time into matching the tyre and rim combo, so the Goldilocks option, the tread will engage as the tyre design is intended and the sidewalls will be stable under cornering load. Yes! So what's the right tyre width and rim width? So previously it was thought, narrower tyres were faster. Yes, there's arguably less rotating mass, so better for inertia, but a wider tyre at a lower pressure actually offers less rolling resistance owing to reduced impedance losses, so when the tyre sort of deforms around ground-bound objects rather than bouncing off of them. The wider, grippier, more comfortable and compliant tyres faster. I'd call that a win. So as wider tyres have been proven faster and more comfortable to ride, even XC riders are seeing the light with more pros running 2.4 inch width tyres. So that size used to be reserved for gravity-fueled riding, but they've also upsized to either 2.5 or 2.6 tyres, which is really common now. This has meant rim widths have gone up too, with an inner width of around 28 to 30 mil or so becoming a widely accepted sweet spot for most. Now, we've talked rim width, so let's talk rim depth. This is another figure that affects, you guessed it, compliance. Generally speaking, the deeper the rim, the stiffer it will be. Those deep section rims are typically more aerodynamic too. That stiffer, more aerodynamic design works perfectly for road, gravel and XC. So unsurprisingly, they'll generally be a little deeper than a trail, enduro or downhill rim. There's no right number to aim for though, as depth of the rim is sort of balanced with things like the rim material, the wall thickness, spoke count to hit that Goldilocks zone between strength, weight and compliance. But speaking of spoke count, the higher the spoke count, the more distributed the load is across the wheel rim and the better supported, the rim is. In theory, that gives a stiffer, stronger wheel, which is why you'll typically see trail, enduro or downhill rims with a higher spoke count, so usually either 28 or 32 hole. Conversely, the lower number, the potentially more compliant and lighter the wheel will be. This is why we tend to see lower spoke counts, say for XC, gravel and road duties, think 24 spokes or below. But there's a little bit more to that. You may find wheel sets that differ in spoke count front to rear, the rear having a higher spoke count for that stiffness, aiding power and transfer and load support, and the front with a lower spoke count to aid compliance, handling and grip. But there are other wheel rim and spoke related elements that can determine not just wheel stiffness but other performance areas. A lot of wheel rims still use a symmetrical design. However, there are some that use an asymmetric rim design. Sometimes it can be subtle, but some brands have really gone to town with this. The idea here is to allow you to get more evenly tensioned spokes throughout the wheel. If you think about it, the flanges on your hubs are asymmetric, so offsetting that spoke hole in the rim helps counteract that. This then helps balance the spoke angle and, more importantly, spoke tensions more evenly side to side versus a symmetrical rim laced into the same hub. More equal tensions means a more evenly distributed force, so in theory you're less prone to snapping spokes or your wheel going out of true, unless you case the daylights out of something, but there's no saving that. But even then, there's the performance benefits of it. More responsiveness and improved power transfer. Now that sounds like a win. Right, hookless. Talk rim design and someone's going to have an opinion on hooked versus hookless, which is fair. Get your opinions down in the comments and play nice. The hook we're talking about is this raised edge or knot on the inside of the rim. The idea is that it will help keep the bead of your tyre in place, even at low pressures. Hooked rims work with almost all tyres out there, but it's worth noting some tyres aren't hookless compatible, so it's worth double checking before you take the plunge. As you can probably guess, a hookless rim means that this hook isn't on the inner wall of the rim, meaning it's got a flat edge. The absence of this hook does come with a tyre pressure limit, but it's only a problem if you're running really high pressures on a road bike, so not the usual pressures you'd have on a mountain bike. The merits of hookless play right into our grubby mitts. The straight-walled design on hookless is not only stronger, but lighter, and the shape of the outermost part of the rim can be engineered to reduce pinch flats too. This is why these new Gradient I30 wheels from FSA went with a hookless approach with a nice wide top section. And then, for the lycra-clad bandits among us, hello friends, and bear with me on this one, the way the tyre's bead interacts with the sidewall can actually make them sit in a more aerodynamic profile. Marginal gains, baby! By not pinching the tyre bead in, it allows the tyre to sit in a slightly wider, in a slightly less light bulb profile. It's fractional, but if you're chasing all-out performance, it's something to consider. And with much improved ETRTO, which stands for European Tyre and Rim Technical Organisation, thrilling, I know. Guidelines making tolerances tighter between tyre and rim manufacturers, it's not only made tubeless options safer, but more readily available. Now, as manufacturing technologies and materials have progressed, we're fortunate enough to have some phenomenal rim designs on the market. Engineers and designers have been able to play with different grades of aluminium, different types of carbon fibre, different types of resin to work with those carbon rims. I mean, the list goes on. One of the more eye-catching features which we're seeing on rims now are these turreted, crenulated, variable height rim designs. Previously, rims would be a consistent depth all the way around. As we talked about before, the depth of the rim is a trade-off between deeper, stiffer rims and shallower, compliant rims. Variable height rims, as the name suggests, have a rim depth that varies, so more material is added around the spoke holes to add strength in that key area. In between the spokes, there's less material, leading to a shallower sections for compliance and weight saving. As an example, this I-30 wheel set is 24mm deep in the spoke nipples and 22mm in the shallower sections, which not only makes it capable enough to take on enduro and some downhill duties, but keep it light enough for regular trail riding. This isn't necessarily a new idea, as we have seen some brands do it a long time ago, but it seems to be coming back into the mainstream now, as there are a lot of benefits associated with it. You might have noticed there's something missing here, and that's the age-old carbon versus alloy question. There are pros and cons for each type of rim, but we've done plenty of videos on that in the past. We're all fortunate enough to be in a time of amazing bike tech, and being surrounded by all this innovative design means we're surrounded with terminology you may not hear anywhere else. So I really hope this has helped clear up things when it comes to all things wheel rims. What would you like me to explain next? Give this a like if it has cleared things up for you. And I just want to say a massive thank you to FSA for letting me have these wheels to help me explain things. I'm Adam, this is GMBN Tech, and I'll see you soon.